All right, so in this video, I would like to look at an MR that comes with a query change. And when we look at the full query, that query is rather complex. And we've discussed that in database office hours recently, how to approach that when there is a very complex query, how to figure out if that change is actually good or if we need to make improvements. And I'm just sharing my screen there. We should be looking at the MR here, and the query change itself is rather small, I would say. So we start at the top. So all we do here is adding columns, adding explicit columns instead of the select star, which is always a good idea. And the actual changes at the bottom where we join users and project authorizations against the other relation. And what we can already tell is since this is the full query as well, so the full query is rather complex. We can look at that in more detail, but there is even a CTE inside, which you can't even see at the moment. There's a recursive CTE, which is sort of a sub query inside that, and the whole thing looks quite impressive, I would say. When you approach that as a reviewer, there are two sides you can, or two perspectives you can have. One is, does the change make sense? Is the performance impact of that change okay? So we would just look at what is the difference that this change makes, and not at, is that query actually okay on its own? Because it might be bad at the moment, right? Even without that change, that query might be performing really badly. And I think it's most important to look at what the differences that this change introduces, because it might just change a part of the query that doesn't make it worse, but doesn't improve the query on its own, and that's probably okay too. And the bigger perspective you can have is, oh, that query is actually rather complex. Is there a way to improve that? And I'll start with the first perspective, so just figuring out what the change is actually, and then we can look where that goes. So I asked if we can have the query before and after that change, because that makes it really much easier to look at. So we have this raw SQL query here. This is the new query, and then below here we have the old query. And what I like to do is usually I would grab that, and I go to my bookmarks and use PG formatter over here to just format the query once, and I grab that and store it somewhere. In the file, right? So this is actually the new query. And same thing for the previous version of that query. Put that into the formatter. The nice thing with the formatter is that you get the same kind of formatting rules for both queries. So what we can actually do is diff those files. That sometimes tremendously helps to understand what the change is from a SQL perspective. So on the left side, we have the old version of that query, and on the right side, the new version. And as we can see, and as we expected, we're changing the columns, so we make it more explicit. So we don't do select star, but select some specific columns. And then the other changes down here where we do a left join on users and the authorizations table. That makes it already clearer what to expect from that change. The other thing we need to look at is, so those queries have parameters. So currently there is, I can see source ID. So that is probably a namespace ID. Similar for here. And then there is also one over here, which is a project ID. So in this case, I would like to get the query plans for .com. And the best way to do that is actually to replace those values with a big project. And what I usually take is the GitLab CE project for that. So I'm just gonna go and do that very quickly, hopefully. I'll just take the new version. So I've replaced those values with the GitLab org namespace, and then there is a project ID, and I'll use GitLab CE for that, right? So it should be all. And same for the old query. All right, let's take a look at the diff. Hopefully that's the same now. Right, we still have the same differences, but those values are different now. All right, then I would go ahead and grab a query plan from a production replica. The way I do that is I actually log into a replica and jump on a pSQL session. You can also do that through ChatOps without having access to production necessarily. I'll just run a explain analyze with that query. And that might actually take a little while. And the first run is maybe even a bit slower because, caches are cold and all that. So even though it's interesting to look at the cold cache behavior, I run them a bit more often to get a feeling of that actually changes things. And as we could see, the runtime is a bit better now, but it's still like at 3.6 seconds. And running that again, lands in the same ballpark, I guess. So that is a good plan for the old query, I guess. So I'll just grab that. And when you use ChatOps, there is also an option to get a graphical representation of that. And you would actually get a link like this. And that's a good way to look at that. I'll just take a note here and put the plan in a comment. And then we do the same thing for the new version of that query. So explain analyze. And once we got rid of all the typos, we should also get a new plan for that. And I'll just run that twice again, just to be sure. All right, and this gives us like a 5-second runtime. So that's already interesting. So I'll just drop that in the visual representation of that too, and take a note here. All right. So in a sense, we can now compare those two plans. So this is the old version of that query, and then for the same parameter values, the new version. And what we can already say is that the change that we introduce, the change from DMR was explicit column names and then joining two other relations in addition to the existing ones. And that change actually makes it worse runtime-wise, right? So we go from 3.7 seconds to about 5 seconds. As a quick sanity check, the number of rows returned is the same, so I would expect this to yield the same or similar result. Now, what we can look at, and I'm just going to start with the old version of that query. I would like to understand better where we spend most of the time, and what is obvious when you scroll through that plan is there is a node here that basically eats all the runtime. It takes 3.7 seconds. That is the majority of runtime for that query. And that is being consumed from this particular node. And we can also see that even excluding all the nodes below that, right? So this is the exclusive column. Even excluding those, the runtime is not much different. So for what it's worth, the index scan here actually is the major contributor to the runtime. And it's also a quite typical example where we use an index scan on the members table here. And as a condition, we put in the source type. So source type equals namespace. That is what the index can do for us. In addition to that, we're also interested in filtering on other conditions, and that is invite token is null, type is group member, and then there is even like a or condition in the end, which goes to the subplan. So here we have two things that we hash from those subplans, and then we figure out on the fly if our record that we retrieve here satisfies those conditions too. And a good thing to look for is actually rows removed by filter. We can see here that this filter, right? So this filter here removes more than 2 million rows. And the index would sort of return quite a few, like a few million rows, and that filter removes most of them, and we would only produce 700 something rows as a result from that index scan. So in a sense, the index is not quite efficient for that query, and we could think about improving that index, or maybe providing a different one. Now, let's figure out if that is also the case for the new version of that query. And as we can see here, this is the corresponding index scan. Nearly the same numbers, right? And also rows removed by filter, similar to the other query. So that is definitely the same here. Now, where do we spend all the other time that was introduced from the change? Okay, and this is something, yeah, we actually added joining the users relation. And this adds 1.2 seconds, which sort of gives us this number in the end. So this is probably the part that makes it worse runtime wise. All right, so taking a step back, I would like to see if we can fix that part. And a way to do that is actually create an index that helps here, so that actually satisfies a few of those conditions, so that we don't have to remove those rows on the fly anymore. And when you create an index, you can't do that on a production replica, because that is read only. And it's probably fine to get a query plan for a select query on a production replica, but you don't want to create an index just to figure that out. So a way I have to do that is we can create production copies, or copies of the production database, and we spin them up in separate instances. And then we can actually promote them read-write. So I have a full production copy in a separate instance. And I can use that to actually mess with the schema or to write to it to make some changes there without affecting the production database. So this instance is a bit different resource-wise, but the database is the same. So when you compare execution times, those might be different. But the behavior and the improvements that you can see, they should be the same on the production database. So just, I'll take the old version of the query because the problem is the same in both. And I'll just make sure we see the same plan here. So this is an explain analyze. Surprisingly, it's actually faster than on the production instance. But worth to know that the instance we're working on is not serving any other production traffic, so that might be a part of the reason why that is different. I'll just shut down my phone. All right, but that gives us an idea of the execution time here. So this is about 1 second. Let's quickly see if we can spot the problematic part. And this is the index scan. Oh yeah, I messed it up. I actually tried it before, and I I left the index there. So I'll just drop the index now. I should have reverted that before trying that again. All right, so without that index, we're back to what the production schema looks like. And right, so okay, this is the original index that was used. As a quick check, let's look at the query plan here. And this in production, we actually use a different index, source ID and source type. And here we just use this one. And I'll just have to figure out if that is something I created. And it is something I created. So yeah, I created 2 indexes earlier to experiment with that. So removing them again. Okay, and that gives us runtime of 2.7, 2.8 seconds. Right, and that is consistent. Okay, and then we see this is actually the index that we were also seeing on the other plans. And we spent a lot of time filtering out those 2.2 million records. So now let us create the index, and this is a bit, okay, I just dropped one of those, so maybe not too surprising, but in this case, we still want to have source type. This is what the current index already provides. And I'll just make that a partial index because this is something we can have as a partial expression. And that would basically make the index more narrow. So it would only contain records that satisfy this condition. And this is what we have back here, where the invert token is null and the type is group member. It takes a few seconds maybe to create the index, and then we run that query again. Sadly, pSQL is a bit broken sometimes. All right, and that went down from 2.7 seconds to 1 second roughly, and we can make sure that the change was actually successful. And yeah, that's the case. So we're using the index that we just created, and the filter condition is also down. So notice that the conditions we put on the partial index are gone here. This is because we directly use that index, so we don't have to do any additional filtering. But what is left is basically the those two plans, or those two conditions, they come from the subplan where we have an unrelated index scan and another rather complex query over here. And this is actually where the majority of records are being filtered out. So this is still 1.8 million as compared to 2.2 before. So it was better. The index makes it better, but it's also not totally like doing away with that on-the-fly filtering. That's probably applicable for the new version of the query too. Just to make sure that is the case, run and explain analyze on the new version too. And we should basically see the same thing here. And we do. So this is the index scan on members with that newly created index, and they did the rest is the same basically as in the old version. So taking a step back, the question is really, I mean, those runtimes are not great. So even the old version of the query is 1 second. This is 2.5 seconds. Still something that we would want to improve, especially if those are part of a web request. You don't want to wait for 1 or 2 seconds for those to complete. So we can look at the query itself, and this is rather like, it's a big query. There is a recursive part in there, which is like, traversing the hierarchy of namespaces we have. So that's not like something that I would want to mess with. But what we can look at is, this is something you can spot here. We basically are interested in members, right? So with some conditions, and then we look for the members ID, and this is typical for Rails finders. That once we have, you filter on members, and then you say members ID is in, and then you put another query selecting members IDs, which doesn't really make sense from a SQL perspective, because you could get rid of that indirection, and luckily, the Postgres planner takes care of that most of the time. It still looks weird on SQL. What we can spot here is we do members ID in, and then there is a subquery, right? And then we do or members ID, so same thing, is in another subquery, and that one is that one comes with the recursive part, right? So the question is, or how we could improve that is actually we can select, we're just interested in selecting member IDs here. And basically this is 2 sets of member IDs. One is the one that comes from this rather simple select, right? So we look for probably all the members in that group. And then there is the other more complex part, which also just yields member IDs, which sort of traverses the hierarchy to extract that. And the way we do that is we OR those conditions. So we have we have one set and then another condition where we say, or if the member's ID is in this other set, then okay, include that as well. What we could do instead is actually use union in SQL, because union provides a way to merge two relations. And in a sense, this is a relation that gives us member IDs and the other ones as well. So why don't we merge those 2 relations with union? So let me see if I can figure out how to insert that. So basically we would replace this with union. And now I just have to get the parents fixed, I guess. All right, but that looks fine. So what we now do is we have basically one subquery here, which is a union query. And this is the first part of the union. And this is the second part of the union, right? So I'll grab that query and look at a plan for it. And notice this is the new version. We were working on the old version, right? So not to confuse that, but the previous runtime of the old version without that union change was about 1 second. And now we can do explain analyze. And this is actually much faster now. Like this is at 70 milliseconds. And we can take a look at the problematic part that we identified before, and it actually doesn't even pick up the index we created. So it even doesn't need the index change. It's really just the union that makes a difference. So one thing I'm also, just as a sanity check, I'm interested in is seeing the number of rows returned. So this is 674. And now, all right, I'm doing that change in a way, and then just rerunning that query again with the old version. And that's still 674 rows. So just as a sanity check, it's always something you can do that is largely different. Then it might actually explain why runtime goes down. Okay, so basically, as a summary, we're replacing the OR with a union here. We don't need the index, and runtime dropped from 1 second with the index to what was it, 70 milliseconds without the index, without even needing the index. There is still one thing we can think about, and that is there is 2 different ways to do union. Union basically merges 2 relations with the same columns, and it would get rid of any duplicates. So just doing select something, union, select something else actually performs removing duplicates. And what we can do here, because removing those duplicates may or may not be good, we can just see if there is a difference with union all. So union all doesn't care about the duplicates anymore. And that actually, yeah, okay, that improves maybe a bit, but it's also questionable, because if that would become a very large result of that subquery because of that, because there are so many duplicates, it may also become a problem for the bigger query outside of that. I would actually like to see that on production, because we can actually do that, because we realize that we don't need the index. So I'll close my read write copy, and just to make sure I don't forget this is production, just looking at that. So this is a production replica, right? And now I can run that old version of the query, and it actually is very much faster than before, like 38 milliseconds, and the whole thing is done. As a reminder, we looked at those plans, and the old version of that query performed in 3.7 seconds. So that's quite good, I would say, as a speed up. And now let's figure out if that also applies to the new version of that query. So we do the same thing here. And just going back to the old plan, so this is at 5 seconds runtime. We grab that. And we run that new query, and even though there was this additional join to the users table, it now goes down to a little bit below 100 milliseconds compared to 5,000 milliseconds. So that's quite good. And with the additional join, the runtime is still acceptable, I would say. At least it's much better than before, where runtime went up from 3.7 to 5 seconds. Okay, so as a quick summary, we looked at the complex query. We formatted it, we diffed it to make obvious what the differences are. We got those query plans. They were in the seconds range on the production replica, so somewhere between 4 and 5 seconds for any of those versions, so the old and the new version. We spotted the index problem where a lot of rows were removed on the fly. We created an index for that, only to realize that, this was improving a bit, but not there was still room to improve otherwise. We spotted the union all opportunity or union opportunity. So we replaced the or condition with the union, and then runtime, even with the additional join, went down from 5 seconds to below 100 milliseconds. So in a sense, this is sort of totally unrelated to the MR at hand. So it's really just improving the overall query. And I would sort of think that we want to ship the union all change here, and then we can also ship the change that we were looking at, because it doesn't make runtime much worse anymore. I hope recording that was sort of useful. If there are any questions, feel free to drop them or reach out to me. Yeah, and I'll see you next time.